so much to Percona for having me today, and for all of you for attending this talk. It's great to be here to speak to you. Briefly about myself, my name is Jordan Moldow. I'm currently a staff software engineer on the database tools and automation team at Box. At Box, we're building the Content Cloud. Box is a secure platform to manage the entire content journey for enterprises, large and small, for them to be able to run all of their business processes on top of. There's three core pillars of the content platform. There's protecting the enterprise's content, offering frictionless security and compliance, empowering the employees of the business or the users of the business with seamless collaboration and workflow tools, and then allowing the business to build more tools beyond just what Box provides by integrating with all manner of second and third party applications. My team, as I mentioned, is the database tools and automations team, which is one of a few teams that work on the relational database infrastructure at Box. Our combined mission is to provide highly available, consistent, performant, and easy-to-use infrastructure for online relational data access at scale. We've run hundreds of sharded MySQL instances, comprising thousands of hosts between MySQL and our data access layer. And it's really important to us to monitor that system, keep it running, and build it out to scale as far as the business needs it to scale. In my talk today, I'd like to talk about delivering the last 10% of a 4-year migration, or the last mile, as you might like to call it. And I'd like to specifically call out some experiments in team effectiveness that I tried running as part of executing on this project. There's three main goals for today. One is just to provide some context to you about what the project was and the level of complexity of it, just so we're on the same page once we move into talking about technical risk management, or what kinds of strategies that we employed to make sure that the project wouldn't fail in unexpected ways or damage our customers in any way. And then the last goal is to talk about some non-technical experiments with optimizing the execution of the team. To start, we'll talk about the complexity of the project. This project was the decommissioning of our legacy mapping database. This database is part of our sharded MySQL infrastructure. And just to give an idea, at the 10,000 foot level, we have a logical application database, which is horizontally sharded between hundreds of physical databases or shards. And then in the past, we had this single legacy mapping database, which recorded the shard of every sharded record in the system. Then we have a credence data access layer, which provides most access to the sharded system for our application domain services. But we also have a PHP monolith, which until the completion of this project was also directly calling into this system. There's some problems which necessitated us getting rid of this legacy mapping DB. Since it's a single DB, it has disk space limits that we were running into. We were having high CPU utilization, which was making it difficult to operate the database and having impact on our users. And also, just since it was a big beefy machine, it cost a lot of money to purchase new hardware for it. It was a lot of toil and run the business work to keep this database alive. And so we really wanted to replace it and then get rid of it. A few years ago, we came up with and implemented a new abstraction, which we called mapping sectors. We replaced that legacy mapping single point of failure with a mapping database that was itself sharded and horizontally scalable. And this was able to save us money and toil. Just looking at a rough timeline, um, you know, originally we designed this mapping sector system to handle 90% of use cases or so. We implemented it, we backfilled the data, and then we migrated over 90% of our read traffic to it. But we still had roughly 10% to go. Um, and I have this phrase at the top, which is similar to phrases you might have seen. 90% of the work takes 90% of the time, and then the last 10% of the work also takes 90% of the time. And that was certainly the case on this project. So sometime after we hit 90%, we had to start thinking about how we were going to move that last 10%. So we spent a while working on the designs for how we were going to achieve that. Then in the second half of the year 2019, we started working on the implementation, and we were able to achieve the milestone of getting 100% of our application traffic onto that credence data access layer. And then we spent most of 2020 doing the final work within the data access layer of getting rid of those use cases that still required the legacy mapping database. And we had this pretty strict cutoff point at the end of 2020 that we wanted to hit for various hardware related reasons. And part of the difficulty of this project, besides those that you might imagine, in order to handle this last 10% of traffic, we had to extend that new mapping sector system to support some very non-standard transactions that existed in the system. And these were some of the gnarliest ones that we now had to deal with. And we also had to deal with some leaky abstraction and ownership issues. For example, some of the processes involved were reliant on and codependent with folder operations, which was owned by a different team. And who knows what else we might run into during this project. So hopefully that gives a pretty good context of what we were doing and why it took 90% of the time, so to say, to actually deliver that last 10% and the challenges that we were facing. Before I go into some of the tactics that we used in this project, I do want to very briefly talk about our box company values, because there's a couple of these values that I take a lot of inspiration from, and I think were definitely instrumental in some of the tactics that we ended up choosing. And so I just want to call them out to start with, and hopefully you'll see echoes of these values throughout the rest of the presentation. So two of my favorites that you could see in my background even: be an owner, it's your company. So that's about, really taking agency over your work. And you yourself as an individual, you can figure out, are there things we should be doing that other people haven't realized that you should be doing? And, you can really advocate for it and do it. Or, potentially work in code bases that you're not an owner of, but you can still contribute to. And then take risks, fail fast, get shit done. Or I prefer to think of it as take risks, learn fast, get value delivered. And with this, we want to, we don't want to be super, super careful. We want to be able to experiment with things, and we want to be able to understand early on if things aren't going to work, so we can roll them back and revisit the drawing board instead of having things fail catastrophically, after you've already put months or years of work in. Two other values: blow our customers' minds. We want to excel at what we do and have people be impressed in what we're delivering. And 10x, which could mean a number of different things. It could be, increasing the scale of what's achievable by 10x, or making a process 10x easier. There's a lot of different things that you can apply 10x to. Bring your blank self to work every day. So, be yourself, and, you don't have to, necessarily conform exactly the way other people do it, We value people for your individual viewpoints. Be candid and assume good intent. So we do our best work when we're honest with each other and we trust each other, and we can approach each other when we have problems without malice or assumption of malice. And then finally, make mom proud. Be a good person. There's also some documented engineering values that are a little more specific that I like to lean on sometimes. Inspire other people to work with you. We produce value when we're very collaborative with each other. Do work you're proud of. I think that's important and doesn't really need, I don't need to say anything else about that really. Do the most important thing first. Just be mindful of what you're prioritizing and don't leave important things to tack on to the end. Have the hard conversation. That's very similar to the candor value I mentioned earlier. Work small and fast. If people are aware of the agile methodology, it's very similar to that. And then build for leverage. That's also one of my favorites. We don't want to, as engineers, we don't want to be doing manual processes over and over and over again. One of our main values is to build automations so that we can spend our time doing higher leverage work. And I'm definitely going to refer back to that later in the talk. So let's get into some of the actual details of how we reduced risk in this project. In order to think about how you reduce risk, first you have to ask, well, what are the risks? What could possibly go wrong? In this particular project, with getting rid of the legacy mapping DB, since there were still some flows that depended on it, especially in particular write traffic, we could potentially take down writes for all customers if we mess something up. Or because we need to migrate from one manner of doing operations to another manner of doing operations, we need to make sure that as we switch between those two, we're not going to accidentally introduce corruptions in the new system. There's the possibility that we could introduce insurmountable scale issues as we build out the new system, that it might not work as well as we hope. And the worst of all are the unknown unknowns. Is our design actually going to work? Are there dependencies on the legacy mapping DB that might come from unexpected places that we won't actually be able to get rid of? These were all very pressing on our mind as we went through this project. And I'm going to talk about some tactics that we used in order to address pretty much all of these. The first risk of taking down rights for all our customers, we were extremely careful with this rollout. The right behavior could be split up into a bunch of different subsets of behavior that happens along different write paths in different scenarios. And we could roll them out semi-independently. And so we created a feature flip for every single one of these different scenarios. And those feature flips valued between 0% and 100%. So we could really have very fine-grained control over how much traffic was going to the new system versus how much was only going to the old system. And additionally, we created some test users and had some special feature flips where we could turn on the write traffic only for the test users. And with all of these feature flips combined, we had about 50 plus that were involved during this year and a half long project. And that's not only write feature flips, there were also other kinds of feature flips besides writes. It also includes reads. So on the reads side, we could potentially introduce problems with returning bad values, either because the data in the new system was wrong or because the way we were querying or returning results was wrong. And so at a number of points in this project, we created dual reads where at a certain point of the code, we would hit the request to do the read. and we would split off into two tracks, the old code path and the new code path. We would return the old value as soon as it was computed, but then once the old and the new values were both computed, we would compare them and then emit metrics about whether they compared equal versus unequal. And we tracked this very carefully as we rolled out in order to see whether the differences were what we expected or if they were far off from what we expected. And we could also log and analyze the mismatches in a more detailed fashion as well. There's a lot that could be said about dual reads. This could be a whole talk or blog post of its own, but for now, I'll just leave it at that. Scale could have also been an issue in creating the new system. It might have been slower than the old one, potentially by a, a huge amount. And so we had some existential questions that go along with that. Is the storage consumption of the new system going to be reasonable? And is the growth rate going to be reasonable? We were also designing a sparse data structure. And so we had to think about how we would garbage collect the data that we were creating, and would that be possible and efficient? We also wanted to make heavy use of caching, but we had to be sure, would the caching be efficient? Would the cache invalidation problems be so great that we wouldn't be able to make good use of caching? These were all very high on our mind. And we identified these existential questions early on, and we couldn't necessarily work on these problems first. We certainly would have liked to work on these problems first. That way we could know for sure that they were solvable. But some of these problems depended on first having solutions for more simple things first. And so this was a risk going into the later stages of the project, but we tried to be more certain that it wouldn't be a problem by at least having high level designs that had enough detail in them that we felt pretty confident in them as we were moving forwards. This is also related to just the general question of, is our design actually going to work? And so remember back to one of the box values is about failing fast and getting shit done, and learning fast when you fail. And so very early on, before we started writing the production code, we started writing first a throwaway proof of concept, which we could run against our entire functional test suite in order to get early validation that the design was sound. And as we were designing the production system, after every stage, we would test it manually against test users. And this was before the entire thing worked end to end. So we knew that when we were working with these test users, some operations were going to work and some weren't, and we might corrupt the data on those test users. But that was okay because we just wanted to validate the part that we did know should work. And so at each stage, we were able to validate that stage before moving on. We also had to worry about if there was traffic that we weren't aware of. For that, we added some additional verbose logging in our data access layer so that we could see all of the queries that the data access layer was making to the legacy database on behalf of raw queries from clients. We could see those queries and see whether they were things we had already accounted for or not. There was also the possibility of queries that were bypassing our data access layer altogether and just going directly to the database. For that, we were able to get access to MySQL and in a cron, look at the access stats and see what IP addresses were making queries to that database. And we were able to take those IP addresses, and in most cases, we could just do a reverse DNS lookup and get the host name and then confirm whether or not it was an expected source of traffic. In other cases, the IP addresses corresponded to pods inside Kubernetes, which we couldn't reverse DNS lookup. Luckily, we were able to use an internal tool to take those IP addresses and reverse look them up to the pod names in Kubernetes so that we could confirm that they were expected. That's how we de-risk the project technically. Now I want to talk about something a little more personal, which is how we did experiments with optimizing execution on the people side of things. And there's two high-level tactics to pay attention to in this last section. One is this idea of experimentation, where teams can experiment with new ideas of how they operate. And then reflection, where I strongly believe that leaders and individual contributors should be mindful of how their team is organized and whether their team organization is being effective and how you can change that organization in order to impact your success. The most important thing by far in here is to make sure that you're doing retrospectives with your team. It's kind of an auto update for your team where your team could be the most dysfunctional team, but if you're able to get together and do a good retrospective, you can get your team back on track. And there's two specific tactics that I want to call out here. One is to avoid anchoring. You really want to make sure that people are able to be candid with each other and that people don't change what they speak about based on what other people have decided to talk about. So I find it helpful to tell people to brainstorm ideas privately and then share after about 10 minutes or so. And that really helps make sure people are thinking and bringing up their own ideas. And in retrospectives, what I've seen is people tend to brainstorm things that were good, things that were bad, and things to try. Often the things to try isn't specific enough. They can be really vague and there's no follow-up. I find it really important to filter the try section down to a few concrete actionable action items and then make sure you follow up on them by giving them a driver and putting them into your next sprint. I keep mentioning this, but being candid is very important. These kinds of projects are very stressful, and to add on to it, the pandemic was additionally stressful. I think it's very important to be vulnerable with your teammates. I think that really helps build trust. And if you're vulnerable, your teammates will feel that they're able to trust you and be vulnerable in return. And you're able to build more camaraderie and work together to find solutions to your stress. And I think being real with each other helps you find humanity in each other and humility, and you can help mitigate imposter syndrome. Another aspect, focusing specifically on the pandemic, is how do you get shit done while you're working from home? In our office, we could very easily meet in a conference room or at a whiteboard and work on things together. One thing that we instituted was something called a group GSD time, where we would block out the same 2 hours every other day and make sure we were all free at that time. And we would prioritize discussions or helping unblock other people via, for example, code reviews. That way, you know that if you need to have a discussion or you need someone's help to unblock you, that time will be coming up soon. And we found that once we instituted these, we were gelling a lot more and we were unblocking each other a lot more. We had a Zoom room that we could join to have discussions during this time. And I mentioned on the previous slide about how we were very stressed. And one thing that helped was to have a team PTO day. That way, everyone could get a day off and recharge, and there wasn't like a lone person working that day who couldn't get anything done because no one was around to help them. And that idea came out of a retrospective, again, highlighting the importance of retrospectives. We also did some interesting things with our sprints that I want to call out. One is that we experimented for about the last 2 months of the project with 1 week sprints. The impetus for this was that we could keep our sprint board less noisy and thereby reducing the pressure to context switch. That way, you'd be more focused on getting your thing to truly done. And if we did need to change our tactics, since we were doing it in 1 week increments, we could pivot every single week instead of every other week. We also previously had columns in our sprint board for things that were in review. We removed that. That way, we would make sure that we were getting it from in progress all the way to done, and we weren't trying to pick up new tasks as soon as we got it into code review. And that helped us make sure that we were actually delivering value before trying to pick up extra work. Finally, I want to talk about long-term retrospectives. There's a lot you could learn from projects like this, and you want to make sure that when you start your next project, you can take those learnings and forward them on. So at the end of large projects like this, um, or at other milestones, for example, the end of a quarter, or when you abandon the project, or you're disbanding the team, it can be very helpful to do a longer retrospective with more targeted questions. That way, you get deeper learnings that you can carry on throughout your career. And in my opinion, a project isn't done until this retrospective is complete. And here's the template that I like to use for my retrospectives. I'm not going to go through this now, but you could refer to it later if you want to take some ideas away from it. So to review, there were two key tactics that I focused on here. There was this idea of experimentation and not just going along with the status quo. And in order to achieve experimentation, really reflecting on how your team is organized in order to identify where you can be making improvements. I want to call out two specific learnings here. One is to build for leverage within your team. I mentioned this phrase, build for leverage, earlier in the presentation with regards to one of our engineering values. Here, we're thinking of it in the context not of a technical variety, but of an organizational variety. You can build organizational leverage by making sure that your team's operations set you up for success. The other idea I want to leave you with is that if you're a technical lead and you're a staff engineer, achieving success goes well beyond your technical strategy. Even though you're not a manager, you can also be responsible for achieving success by making sure that your team is operating to the best of its ability. And if you have ideas that you can experiment with in your team to deliver not just technical value, but organizational value that can then drive technical value, you should absolutely do that, even as a non-manager. To summarize, we had these three pillars where we briefly discussed the complexity of this project. Then we looked at the technical risk management that we used in this project. And then just at the end here, we talked about how we were able to optimize execution with various experiments with how our team worked. And that's it. That's how we worked on the last mile of this project, and we're able to deliver that last 10% after 4 years. If you're interested in topics like this, Box is doing 2 other talks at Percona Live. There was a talk that by now should already be available on a change data capture system that we built as part of this project, and that is presented by my coworker Venkat. And tomorrow, I'm giving a talk on one of the data structures that we created as part of this project, and so that one will be a little more technical. So thank you very much for attending. I hope it was very useful. If you would like to discuss any of these ideas more with me, do feel free to reach out. I welcome this kind of conversation. So again, thank you for attending and enjoy the rest of your conference.